Good afternoon, everybody, and welcome to the RanchCast. My name is Jason van Brackel. I am the Director of Community at Rancher Labs. So let's get started today. So if you'd like to join us today, there are a couple ways that you can go about doing so. The first is to join us on Twitch. If you'd like to join us on Twitch today, you can find me here on the RanchCast. Let's see if I can hear myself. So yeah, you can find me here on the RanchCast. Twitch.tv/the RanchCast. Please subscribe. And if you type into the chat room here, you'll get a hold of me. As well as that, you can also join us on our Slack channel. So if you wish to join us on Slack, navigate over to the RanchCast channel. So if you'd like to join our Slack, you can do so right away by joining slack.rancher.io. So if I bring myself back up, slack.rancher.io, you can join our Slack channel right now and participate with us today on the RanchCast. So today we're going to talk about, I have so few channels. Actually, I turned them off for that because, I just don't want to be showing anybody's name. But yeah, so today on the RanchCast, we're going to talk about the new Terraform Provider for Rancher 2.0. The Rancher 1.0 Terraform Provider was really, really popular. So we wrote one for 2.0 and it went through production. So if you want links for today, you can check out our blog post. So we did a blog post last week, or I think I wrote that thing. You go to rancher.com/blog and actually type blog properly, you'll get the introduction to the Rancher 2 Terraform Provider. And there'll be some links in here. And I may update the link with this RanchCast after the fact. But afterwards, if for some reason you have to jump off or you can join us, join and subscribe our YouTube channel. Because when I get to 100 subscribers, I can get a name that doesn't look like this. So to find us, you really have to say the RanchCast. And then you have to say, hey, you were looking for this, the RanchCast. And there we are, right there. Because, the Ranch is also a cool show. So with that being said, let's get started. If you want the source code for today, I'll put it in the description in YouTube. But it's also available via github.com/Jason van Brackel, me, and my Terraform modules. So whenever I need to build out a demo environment or I'm doing a blog post with some technology, it ends up here. And what we're looking at specifically today is this managed Linux Windows hybrid Azure. And I know all of you don't like Azure. Azure. Yeah, I was a Microsoft dev for 15 years. Azure's the thing I have the most Terraform of. So I decided to do this on Thursday, announced it on Friday, and presented on Monday. So I grabbed as much existing source code as I had, and we'll actually grab that now. So I'm going to go ahead and go to the Terraform modules, grab and go ahead and clone this. Let's grab a terminal window that is actually large enough for you to actually read. Git clone, and feel free to grab that. So for those of you unfamiliar with Terraform, it is a HashiCorp product. It's a really cool HashiCorp product called Terraform.io, and it's really creating infrastructure as code. So we'll do a number of the RanchCasts on infrastructure as code, on Kubernetes as code, on Rancher servers as code. The idea being that you automate all the things, so when things go really bad, you can rehydrate all the things from quickly from backups and from infrastructure and software as code, or software deployments as code, which is the idea here today. And so to find the Rancher, a couple of links to help you out. Go to Rancher or Terraform.io. Docs providers, Rancher 2 index, and this is the documentation we're going to work off of today. Now, a number of you have been working with this provider when it was in development because I gave you the link for it because you asked about it, and that was at github.com/rancher/Terraform Provider Rancher 2. This specific repository has now been archived, so it has been archived, and everything should be going to the actual Terraform provider since this is now in. This is in the HashiCorp's, the Terraform CI/CD process and code process, so all the commits should happen here. So any pull requests, any issues that we find today that we'll write out, we'll make sure that the issues are in here and that the code additions are in here as well. So if you want to know how to get started with this provider, you can build the provider. It's not that hard. I did it for my early version, for the early versions, and then we'll walk through. We'll get started here as well. So let's actually, now that I have my code up, and let me make sure I don't have any passwords on the screen. Let's see, we'll go to the README first. So this is the RanchCast episode 1. You all watched episode 0, which was our soft launch. We're still kind of in soft launch only because I just haven't bothered to announce it yet to the world. So you all get it because you're paying attention on Twitter or on Slack, and you see me announcing it. So there'll be a more official announcement coming from our blog site probably next week. So let's take a look at let's take a look at what's in here. So again, this is Azure based, and it's remarkably simple. So there are a few things we're going to have to fill in. We're going to need our Rancher URI. We're going to need an API token. I'll show you how to create an API token, and we'll also need for whatever cloud you're in, you need some way to talk to that cloud. And Azure happens to be a service principal. It's client ID, client secret, and some other things. Region where we're going to put it. Some standard node sizes. Username, password. Windows nodes have to have the password. It's not like an SSH way. There probably is a safer way to do it. I just haven't learned it yet. I'm still kind of figuring out I'm still figuring out WinRM because I usually just install Open SSH on my Windows nodes and use SSH for everything. And of course our different node counts. So today we're going to actually do a custom platform. And for those of you familiar with Rancher, I'll actually open up and do one of these by hand first. And then we'll actually execute the one in Terraform. So if you were to add a custom cluster is the most flexible option. It assumes two things. One, that you know how to spin up your own IaaS, and two, that you know how to install Docker Engine. So that's it. If you can do those two things, you can do custom workflow and do Rancher clusters. This is your on-prem option. I mean, it works in the cloud too. We're using Azure as our on-prem stand-in. And spinning up one like this is just as easy as saying custom, selecting a few options, selecting a network provider, whether we're going to enable Windows support, project network isolation, and talk to a cloud provider. And we won't go through everything here, just an idea of where we are in the UI as far as the type of cluster we're going to create today. And then for each operating system and for each role, Windows only having worker roles, we select our role and we get the slice command line here, which means we're actually going to have to deal with that in Terraform today. And as I played with this, I figured out that it wasn't 100% obvious. I had to look through the Terraform state provider to figure out a few things. I'll probably be putting in some pull requests for documentation changes, just more examples, make it more obvious, that sort of thing. So as we're getting started, I'm just going to check to see if any messages yet from the community. Using Terraform demo for a lot of reference. Does this use the same provider? The Rancher HA Terraform demo. So I don't know. I have to actually look at the Rancher HA Terraform demo because I didn't write it. This is actually a little bit different because this is the Rancher 2 provider. So the Rancher 1 provider, tied into Rancher 1. Rancher 2 provider ties into Rancher 2. But I don't know that demo specifically. Good question. And let's check Slack as well. See if there's any questions out on Slack. Not loading. Okay, it is live because I was able to bring it up. So whatever browser plugins you might need, I don't know how to troubleshoot Twitch very often. So, but I'll come back to the screen. All right, so we're going to walk through the Terraform provider. The provider usages, you just need a API, or a URL, and either an access key, secret key, or a URL token. I actually prefer the URL token myself because it's just one thing. And if we look at our main area here, and so these are other things you need. Some of them are optional. If something's not optional and you ask Terraform to go get it, it will then yell at you. So I'm actually going to launch this thing first so easy way to do it, just copy, paste in here, change the name, remove example, and then it's just fill in the blanks. So I have already made one because I was playing with this morning, making sure that everything was good to send you all. The Windows stuff feels a little hokey. I hope I fixed it, but I haven't had a chance to test it yet. But I'm going to close this down. I'm going to move this off screen for a moment so I can put in my actual token. And I'll actually get that running as I show you how to launch your stuff. Because it does take 5 or 10 minutes to launch all this stuff. Actually, the last one took about 7, so it wasn't bad. But I've had the Linux nodes launched in as short as like 1.5, 2 minutes. So I'm grabbing that, putting that into my variables file, and I'll make sure that you're not seeing that. Now, if you are following along and you have an Azure account, you're going to need a service principal. So you can find everything you need to know about service principals, about creating identities, not Azure Stack. Azure Stack's the on-prem. We want the not on-prem stuff. So you can learn everything you want to know, then some. Really, that's an old article. Well, all you need to know, it's really a service account, but it's a service account tied to a tenant and a subscription, and it's an Azure way of doing things. But you'll need one. So if you need to create one at any time, you can do so from the Azure CLI. You can get that via Snap, apps, a few other ways. Check your documentation. It's actually easier I find it easier to use the CLI than it is to use the portal. Just recognize that there's some idiosyncrasies between AZ here in Linux versus AZ in Windows, AZ in PowerShell, and AZ in the cloud provider. So I write a lot of PowerShell and Bash scripts. Like I said, Windows guy for a very long time. So AZ, we have all the things that we can do in AZ. We're specifically looking at AZ-AD, which is Active Directory graph entities, not to be confused with Active Directory as an Exchange server. Completely different thing. The occasional beep you hear is just the battery backup on my Fios the battery has just died. So somebody asked me about that earlier. AZ-AD-SP, and you're going to do create for RBAC. You're going to want to give it a name so that you can remember what it is. I already have one created, so I'm just going to give you a name like test. And then usually you'll give it a role as well. The default is this role, and this is the role you'll need. I would also recommend scopes. So scopes, you'll use the fully OAuth path for the resource groups you want to work in. This scopes your service principal so that it has least privilege. So I'm not going to hit enter on this. It'll create one. It'll feed you back all the things you'll need and the password. And I don't want to create one that's recording live here. So yes, you will need that. In addition to that, you'll also need an API token in Rancher. So let's create one. So I'm going to go to my cluster. I've already gone through and created one. You see this custom one I created by hand is waiting for control plane etcd. You can just remove that. And drop down and go to API and keys. So something important to note. When you create an API key in Rancher, you are doing so with your own credentials. So the token you create has as much RBAC as you do on both Rancher and the Kubernetes clusters that you have access to. So keep that in mind. If you're a super powerful admin user, you're going to want to not create a key for everyone. And you're going to add key, give it a fancy name, and set it to how long you want it to expire. I would suggest you rotate your keys fairly often. I might even have code to actually do API keys by code. Yeah, I have them somewhere. So maybe I'll put that in the description on the YouTube video. So you'll put when to expire and the scope. So no scope means globally scoped. It's Rancher and all the clusters managed by Rancher. In this case, if I scoped it to this, it would be RBAC. It would be an API key specific just to that cluster and your RBAC on that cluster, which is actually really useful for CI/CD scenarios where you just want an automated actor to do application deployment for a specific cluster. So that'd be a good place to use that. And we'll just when you hit save, you'll get the client key, the secret key, and a full-blown bearer token. I use the full-blown bearer token in this example. Let's go ahead and cancel that. And back to global. So let's see. Let's see what can I hide on here without showing too much off. Yeah, we can do that. So my TFRs. Now I have my service principal in here with my client, my secret, cluster name, I'm going to use demo password. And so what you'll also need is what region you want it in. You'll need an admin password for all your Windows machines, because they'll actually need an admin password. And then your public SSH key to stamp the Windows Linux or the Azure Linux nodes with, and your SSH key path so that your Terraform can log into those boxes and manipulate them via the provisioner. So I'm going to just do one of each because that's fairly fast, and I won't run out of CPUs because I don't know if I turn off my limit. Up top, let's just we'll just remove the token for a second. I'll put it back when I'm done. So here, and I'll remove the secret key for my Azure Service Principal, and the rest should be fine. So you can see now, in my variables file, I have, do not click on the wrong thing, I have my Rancher URL here, and my API token is filled in, and my client secret for my service principal, so I have enough to build out a cluster. So we're actually going to run this, and while it's running, so we'll have some time, we'll go through what it's doing. So again, I'm going to pull this off screen, fill my keys back in, and everything looks good there, consistent with what's in memory. So let's go ahead and get Terraform set up. So I'm going to bring my terminal window back over. Now that we have everything we need, we'll clear the screen. I'm in the right place. Yep, I want to go to my managed. So first things first, you're going to want to do a Terraform init. This will pull down the Terraform providers that you need. So it's grabbing the Azure ORM. Since I'm in Azure, you'll grab the one for your provider if you're in AWS, or if you're in DigitalOcean, for example. And then it will also grab the Rancher 2 provider. So this is now successful. We're going to do a Terraform plan. I always recommend doing a plan first to see what gets created, especially what gets destroyed, which is kind of more important. And we can see here it's going to create all kinds of Azure-y stuff, but the one we're really concerned with is the cluster. We're actually going to have a cluster manager, which is the job is to manage this cluster. And I'll show that off in a second. Let's actually get this running. I'm going to Terraform apply. And if I forgot anything, the really nice thing is it will yell at me and ask me to fill in any blanks. But I think I have everything filled in. So it's going to add all those things that we said that's in plan, and we're going to say yes. And so now a whole bunch of automation is happening. And already, if we log in back into Rancher, we'll see this new cluster, because custom cluster is really just an empty definition, waiting for our various node types to call in, and they should. In addition, if we go out into Azure, and we'll do that as well. Watch this thing being created in Azure. And I show my resource group. Yeah, my resource group has already been created, and it's already going about the process of spinning up disks and network interfaces and security groups and nodes. So just like I would, just like I would on any cloud or on-prem, I also be concerned with my firewall. So I have my network security group actually doing proper ports for this cluster as well as it's being created. So let's actually walk through what this thing is doing now. Turn off. See anything sensitive on the screen? Nothing sensitive there. Don't need to save that. All right. So let's take a look through here. First things first, the variables. So you need a service principal. I defaulted a lot of things to make it easy for me. Make this easy for you. So I default to ECUS because I'm out of the Philadelphia region. Everything, pretty much everything else I don't default. I have really small node sizes for control plane etcd and my workers, and a slightly larger one for my Windows worker, so it will behave. I set my node images. So for my Windows worker nodes, those are 1809. If you watch the Windows container video, that should look familiar to you. And then the Linux node image, I use Ubuntu 16.04 because that's what I've tested with. I haven't tested with 18 yet in Azure. And then, of course, Rancher API tokens. So anything required that you don't have, Terraform, when you say Terraform apply or Terraform plan, it will ask you for them, which is really kind of nice. So while we're here, let's check for questions. Go back to camera only. Let's see. GitHub.com/Rancher/Terraform modules. Do you recommend using the Rancher OS image or Ubuntu? Yes. It's really whatever your organization is comfortable with. They both work great. Rancher OS is not a requirement for running on Rancher. Rancher OS is generally for, you want a small attack surface. It's enough Linux to run Docker, so you have system. Everything else runs in Docker with system services, and then services at the user level as well. So you have system Docker and user Docker, and it's our three-letter agency customers and finance-based customers love it because it has a really small attack surface. Good question. Let's check this. Let's check Slack as well. Oh, let's see. Oh, cool. People are following along. Awesome. So Twitch channel. Oh, and there's the link at the start. So thank you all for joining us. I really appreciate that. So we looked at our variables. Let's go back to the code screen so you all can see it. We're looking at our variables, outputs. I'm just outputting two things for testing. So to join nodes to a custom cluster, I need the node command and I need the Windows node command. Oh, that's spelled wrong. Look at that. That's actually not going to spit that out. It might even error on me. So let's just make the change now. It's nice when you can spell, which makes me wonder, did I copy and paste that from code where it's just not going to work? Or is it actually going to work? That's a good question. But we'll check that when we get there. So going back to main, let's take a look at what this is doing. And this thing is huge because I wanted it all in one for scrolling and demonstration. You don't have to do that, and I annotated throughout. So we have our providers. Again, we need our service principal to automate Azure, and then we have a Rancher provider to automate Rancher. So I don't need this because I have a fully qualified certificate set. But if for some reason you have invalid certs, you can actually ignore that by going to insecure. I would recommend against that. But for development purposes, for testing out if things are working properly, no reason not to do that. So for Rancher, this is the only resource we need to actually spin up a cluster. There are a lot more things we could do, and maybe we'll experiment a little bit with this while we're here, depending on how we do with time today. So we have our Rancher cluster resource. I'm calling it manager, and I have a variable for name. And we're using a category called RKE config. So all of if it's a Docker machine workflow, or if it's a custom workflow, those using RKE or Rancher Kubernetes Engine. If you want to know more about Rancher Kubernetes Engine, you can check that out. It's also an open source project on the Rancher page. We'll open the window, and it's github.com/rancher/RKE. And if you want documentation on that, as far as how this thing works under the covers, because it's also a CLI tool, maybe I'll do an end-to-end CI with Rancher, even setting up Rancher via automation. This is just kind of part of that. And then so if you want to go out to, I like docs.rancher.com because it just helps me think that way, but it's actually rancher.com/docs. You go to RKE and see everything about actually configuring clusters by YAML. I'm sorry, it is all YAML. So anything we could do in here, we can also do in this custom workflow as well. And then we want to use a cloud provider. Now I could use a different service principal per cluster, but I'm just happy to use the same service principal to set up my cloud provider right here, just as I would in the UI earlier. And then we're setting up an Azure resource group and all of the networking. So it's just sets of different Azure objects. My network security group with my actual firewall rules for the Kubernetes cluster internal, as well as access from the outside world. Now this example is a fairly insecure example because I set up WinRM, which is Windows Remote Management, in a very insecure way. There are better ways to do it. This was just the quick and dirty way that I already had code ready for, because I put this together in like 2 days. And we have see here all of our security rules for the different Kubernetes components, for my etcd components, and for my worker nodes. So after that, we have our public IPs. So I put public IPs on everything that's development level. You may not want to. You may just want to might just want to set up a Bastion node and do all of that. And RKE can handle Bastions as well. And then we set up all of our NICs and all of our VMs with our various elements. And we do this is the important area. So scrolling down to the important area. So We need to be able to run SSH and WinRM commands to have these nodes join the cluster. So that specific variable is the cluster, its name, which I called manager, you saw it earlier, and we need a cluster registration token, and that cluster registration token is it's a map in Terraform. And I grab the Windows node command, and I'll show you the Linux node commands because there's some modifications we have to make. So the Windows node command by default assumes Hyper-V isolation. Hyper-V isolation is still very much in testing and in development in the Kubernetes world, so strip this off. So you can use a replace command to do that. Follow example code. And WinRM has slightly different ways of doing things with username and password. And then my other machines, my worker, etcd, and control plane, the remote exec is a little bit different. So I'm actually installing Docker first and adding and making sure that my admin user is part of the Docker group. And then I'm running that node command and adding its role afterwards. So to the -- worker, -- control plane, or -- etcd. If you want to do multiple, I would just change this from like -- worker to -- worker -- control plane, for example, and that would work. And then that's where we actually need the SSH key paths. This is actually going to my private SSH key to make those commands. So, and that's Azure VMs in a nutshell. So, this remote exec provisioner will still work just fine in other virtual machine environments. This is, the provisioner is actually generic. So let's see how this thing is doing now. Hey, look at that. That looks like it's actually talking to the Windows machine. Hey, good, I fixed my Windows code. But I bet the Linux ones are already done because the Linux ones take a lot less time. So let's take a look at Rancher and see what's going on here. So we have a RanchCast cluster. We now have, now have a 4-node cluster. Oh, that's gonna be interesting when the Windows node tries to join this cluster because the Windows support. Oh, what's it? No, I'm using 2.2. It still won't quite work. It won't work right. It'll be odd because we've got an 1809 server and an 1803 feature. So for those of you who haven't seen any of the Windows stuff, our early experiments were with the pre-GA version of Windows container support in Kubernetes, which was Windows Server 1803 rather than Windows Server 1809. And then later, and then we've in our 2.3 preview, which I demoed last week, you need Server 1809. So I think I'm using a Server 1809, which will cause some interesting side effects here. I don't know if this thing will ever actually safely join. So our worker node actually just came active. Look at that. And then we're just kind of waiting for our Windows node to do its thing. And so so we have a fully working cluster, and this is still doing stuff, and I'll let it continue doing stuff. But I believe it is going to fail at some point, but we'll see. Actually, it'll use the 1803. Oh yeah, it's trying to connect. Oh, look at that. Can't find it. It doesn't need the Azure CLI Cloud host on here. That's really interesting. So, but we'll figure that out later. I'm not so worried with that Windows node. But you can see here we have a full Kubernetes cluster as code in Terraform, and it really was fairly simple. So let's check on questions first because we're only at 2:30, so we might as well experiment a little bit because I'm still loading this thing too. So excuse me. Going back to camera view, questions. If I spin up a cluster using this, is it officially supported, as in can I get support on Rancher for it? Yes. This is an RKE cluster. This would be the equivalent of talking directly to the Rancher API. So the Terraform Provider is on top of the API. So let's go back to my view for a second. So everything in here is backed by a REST API. So I go back to cluster and actually go to view an API. It's just like calling this internally. And we can see the Windows node is not active. So yes, that is a fully supported method of hydrating a Rancher cluster or a Kubernetes cluster from Rancher. Absolutely supported. Good question. Let's go check over what's going on in the RanchCast channel. And no questions there. Okay, then we'll let's take a look around the Terraform provider now. Not code window, Terraform providers, and we want this. So all we had to do for this is we set up the Rancher 2 provider with our token key. Sorry, I'm not sure. I'm showing the wrong window. I'm looking at myself. So we set up our Rancher 2 provider with our API, with our token. So I didn't use the access key secret key like in the example. I actually use this token key here. You can create, like I said, you can create this in code. I'll put a via gist in the description when I move this over to YouTube. But so what other things can we modify from within Terraform? So Rancher 2 settings. So that's basically everything over here. And if you go to global settings, you can modify these as well. So if you want your own way for installing Docker when you're doing Docker machine, that's how we do it. We use the Docker machine node driver. That's how we install Docker. It's actually a really good script. But if you have some other way you want to do that, or if you want to turn off sending us telemetry, if this is all anonymized, please send us telemetry because that helps us make the product better. We like to see what's going on, but all anonymized, just like other companies do as well. Don't change the server URL. I say this every time I demo because if you change the server URL, there will be trouble. So we can also modify auth. So I've got GitHub auth in this cluster, but if I wanted to set up my GitHub auth or my AD auth or my LDAP auth, I could do it right here from within the Terraform provider. So not only can I can use RKE, I could use Terraform to spin up my nodes. I could use RKE to create my cluster. I do my Helm automation, and I then have my Rancher cluster. And then once I have my Rancher cluster, I can tie into it with Terraform again via the provider and spin up my Kubernetes clusters all via code. So yeah, we'll do an end-to-end. We'll do an end-to-end, starting from zero and getting to a production ready, if not close to production ready, Kubernetes or Rancher with Kubernetes clusters. So we can set up all our cloud credentials to talk into the cloud. So if you need your AWS set up, and even your cluster logging and project level logging, we can set up as well. Now this cluster, I don't have Elasticsearch set up, so that would be the equivalent of going in here and actually going into tools and logging and setting up log forwarding. And I'll say the same warning that I say to everyone when I give demos. Project or cluster level logging is a fire hose. So if you pay for Splunk, which you pay for by index gigabyte per month, and you don't want to rename your dog and your firstborn child Splunk, do not turn this on. Because that will, you could, with a large Kubernetes cluster or a whole lot of Kubernetes clusters, you could blow out your Splunk license really fast. And I'm saying that as a huge fan of Splunk. I've written integrations for it. I love it as a product. I'm not paid to advertise for it. Just to let you know. Full disclosure there. So on top of that, I can also set up my monitoring. So that would be something to experiment. Because I haven't tried that yet. I haven't tried to set up my monitoring from within Terraform. So let's take a look at the documentation around this and see how good it is, because I've not tried that. And it was one of those things I think, hey, let's try that. So we need to look at our cluster. And I bet this is, so it's not RKE config. I don't think it'd be RKE config. So monitoring, optional computing, Kubernetes cluster monitor, list, max item is 1. Interesting. You know what? Let's take a look at the Terraform state file and see what we can figure out here. So going back to my code window, we're going to take apart the state file because we can learn a lot about a Terraform setup via the state file. So I did set this up in here. I should have a TF state file. Nope, just had to reload. So Terraform state. I'm sure there's probably secrets here I shouldn't be showing you, but we'll just make it smaller until we find what we're looking for. So I want to look for monitoring. There we go. So RKE config monitoring 1, option 0, provider metric server. No idea what that means. Let's find the next one. So those are the 3. Is that actually part of RKE config? This is where we do a little guessing and testing. All this means is that I need to update this documentation to spell this out. So monitoring, or healing. Yeah, so we have monitoring. or we can learn it by reverse engineering it. So we can actually change it here in Rancher, and then do this is a Terraform refresh. I think we'll have to grab the current state. Yeah, let's do that. So going back into my Rancher cluster, this is a small cluster. I might starve this cluster to death. We'll see. Or wait a minute. This is my Rancher server, so my state. So we're going to poke around in here a little bit. I want to see if I have more than one cluster in here, or just the one. So let's find out. I've got my Rancher. So I want to see how much it pulls out of from Rancher state. Let's see if it finds my. Nope, no JVB. I was going to see if it actually pulled the state for my other one, and it didn't do that. So the question is, how do we turn on monitoring from? Let's do it in reverse. So we'll actually go back and turn on monitoring. This is me thinking out loud. I might just starve this platform to death. It's quite possible because Prometheus and Grafana can use serious amounts of CPU and memory. Yeah, to starve to death. That's okay. Oh, look at that. It's smart. Oh, we need bigger nodes. Well, let's see if we can modify one of these nodes. I'm not trying to do this in Azure, but it's worth a try. So we'll need a worker node. Let's go back into our Terraform here. And we'll need to modify our variables file. So I'm going to pull it off screen. And I'm just going to replace the D2v3, that's the default, and do something a little bit larger. So I'm going back into my TFRs. And variables in my variable name. Let's grab the Linux. It's Linux worker size. Yeah, Linux node image. No, not the node image. I want my worker node VM size. So what I'm actually going to create an environment variable for is this specific variable. I'm going to change the worker node VM size to one of these DAV3s and see what happens. So I'm going to go into my variables file again, pull this off screen, go into TFRs, and that was worker node VM size. Worker node VM size equals much bigger. So DAV3. And now if that's saved, I'll go back here. Oh, look at that. It's still interesting. Oh, it can't. Yeah, this. I knew this was going to break eventually. It's not a big deal. Everything state-wise I'm okay with. Yeah, I know data loss may occur. I'm not really worried about it. Everything in there, I'm not so worried about there. So Terraform, we're going to reapply and create bigger worker nodes. So we're refreshing state about everything going on here. And then, yeah, there we go. We're going to make one change, and I do want to change that. So I imagine that, I wonder if that will destroy, yeah, Azure wouldn't let me do that. Wait a second. What's not available current hardware or current hardware cluster? Let's grab something bigger then. Let's grab a standard. I don't know all these off the top of my head, but we'll grab, I'm going to assume bigger number means bigger machine. I think it's probably pretty safe. So instead of a D8v3, I want, let's do a DS4v2. I'm sure that will be a larger one. Let's try that. So going off screen again. I have no idea how big that is, or if I even have the Azure by default will restrict some things. Yes. Oh, interesting. It is support. It's a supported action. I was wondering if it would let me do that or not. And I bet if we look at Rancher right now, this node is, yeah, it's modifying. So if this node is asleep or dead, or somewhere in between. Zombie node. Windows not active. Ah, so the worker node is still active, even though it's being torn apart. That's okay. The question is will, yeah, I'm wondering how it will show up in Kubernetes via the node API. So that may not actually affect our available usage. Let's see how that's doing. 40 seconds. We look at the portal, see what's going on here. refresh. Let's go in here. That's just the credits. And then, yeah, worker, virtual machine. Yeah, 8 vCPUs, 28 gigs of memory. So it's actually a larger machine now, but I don't think Kubernetes will recognize it as a larger machine because when it registered, it was a certain size. But let's find out. So here's our worker node. Kubelet stopped posting node stats, yes, because we ripped the brains out of it a minute ago. Is it still doing its thing? That's the question. Oh, look at that. Oh, and it gave me my... Huh. First thing. Terraform output. Yeah, I did something wrong with my output too. I'll work that later. So that modification is complete. Will Kubelet start posting again? We might have done something evil to it. That's okay. Let's SSH in and see what kind of evil we did to it. This is the fun thing about live streaming. We can experiment with this stuff. Oh, let's find another fun thing here. So I want my... I don't need a SSH key. I use my own account. So I just need the IP address, which I do need. So grab that worker's IP address, IP, clipboard, SSH. You are alive. So there should be a bunch of Kubernetes-y things running in Docker PS. Oh, they're all coming up. Okay, that's good. Docker PS. Let's prep for Kubelet. No Kubelet. So Hypercube. Oh, it's a lot from Hypercube, so I do have a Kubelet. So Docker PS. Yeah, there's Kubelet right there, up 47 seconds. So, the question is, did it come back? Oh, look, it did come back. It's very nice. Oh, and it got the memory update and the CPU update. Awesome. Hey, cool experiment. Glad you joined me there. So let's throw monitoring. And save. So now Prometheus and Grafana are going to be added here. But what I want to do is do like a Terraform update, and then see if see how the Terraform state might have changed. So when we look at the Terraform state before, pulling this over my screen. So we looked at the Terraform state before, we could see monitoring. So we saw this monitoring 1, option 0, provider metric server. So let's see what happens when we, I bet it just flips this to a 1. So I don't remember this Terraform command off the top of my head. Let's get it here. It's not here. Let's see what else we can do with it. I want Terraform, not graph, not import. Update local state. Oh, good. Terraform refresh. So Terraform just released the really cool, no more state files, the cloud, the cloud Terraform state storage. Really cool idea by HashiCorp. So monitoring, did this update? Did it not? It's Terraform TF state. Monitoring 1, options 1. Oh, interesting. Next, metric server. Oh, so I'm gonna ask about that. So I want to know how to do that. Maybe we'll just change it here and watch what happens. Let's check for questions, shall we? No, nothing over in the world of Slack right now. Anything new over here? Let's see. If I split this cluster, where does it spit out the kubectl config file? So kubectl, good questions. Well, where does it? We don't always do documentation. We do it live. Yes. So back to the screen. Yeah. So I'm learning this thing as much as you are. We've been using this internally for a bunch of our stuff already before it went live. But I have the amount of things I've done it for has been pretty small. So we have to learn this together. So let's go ahead and just put Ranch in. No, don't want that one. So this is now running, I believe. Yeah, it's enabled. So if I go back to my cluster, I have more information. I can still see my Windows node is down. And so monitoring is now on, and we wonder where the kubectl file is. That was the other question. So let's find the kubectl file. That should be part of the cluster configuration. So if I go into cluster, I go to kubectl, there we go. Let's see, master DNS prefix. Is there no way to access that config? Yeah, that's not going to help us. So it would be an element of the cluster. Oh no, that's an element of the user. I don't know if we could get that kubectl file this way. I do have scripts to pull the kubectl file. That's a really good question because when you create the cluster, you're creating it with your user, but you're not exposing your user via Terraform. That's a really good question. I'm going to write that one down. I like that question. You know, how do I get the kubectl for that cluster? So maybe come Friday, we'll do a questions follow-up. So yeah, if you've any questions about what you saw today that you don't get answered now, or you start experimenting, you know, go out to the RanchCast channel on Slack. So if you weren't here earlier, you can join our Slack via slack.rancher.io and just join the RanchCast and go ahead and ask some questions there. Maybe come towards the end of the week, we'll do a redux on this and actually answer some of the questions because I'm actually curious how I would get my kubectl out of here. I could get it from SSH. I could SSH into one of the nodes and grab it that way. I could actually grab my admin kubectl that way. There's got to be a better way, though. Yeah, good question. You could also pull it out of the Rancher API. So if I went into here and said view an API, I bet there's a path here for kubectl. Oh, generate kubectl. There it is. So if you call this action, actually, here, let's call this action, shall we? We can call this action right from the API and show our request and send the request, and we get the output. And that is that's a kubectl file. So yeah, you could just curl it. That would work just fine. So yeah, good question out there. How would I get my kubectl off of my cluster? Yeah, you could just curl it. So remember, just that kubectl is access to your cluster, also like the API key with your RBAC. So we're about quarter of. We did our monitoring test. I actually want to see. That was the other thing I wanted to do was the Terraform. Oops. I wanted to see if we could adjust monitoring from the RKE config. So what I'm wondering if we could do is I could go to RKE cluster, go into this RKE config and adjust monitoring. So we'll say it's a list and it's 1. Monitoring list 1. Don't have an object output for it though, do I? Yeah, I don't think I'm going to play at that. Why not? Why not? This is a test cluster. We can feel free to break it. So let's go ahead and main. Let's go to my RKE config. No, not Control G, Control F. And it said monitoring is a list. So network is, let's just compare these. So RKE config network is it's one of those things where because I'm not an expert in this, optional RKE configuration, and then GKE config. Let's just RKE config and say, no, not network. Monitoring. And we'll just say the first one. And then let's say, what would we hit? We had provider, we had option. Let's go with TF state, and we'll just guess. So monitoring 1, change monitoring to, that's its number. Let's do 0. Ew, this is ugly. Yeah, I'm not going to mess with that. I don't know. I don't actually know what it's doing here, so I'm going to skip that. And we'll look for one more question, and then we'll close things out for the day. So, any more questions? So can I share the script? Which script? So let's go ahead and close that down. Let me save that change. Let me save the TF file. Oh, I know what I did wrong here. I put a string in, not an actual, hey, let's grab the output. This is what this should have looked like. That's why I just got strings. Because if I wanted to manually add clusters later or add nodes later, I could do that with those two commands. So that's the mistake I made on the output. So now if I do a Terraform, output now, oh, I just got to apply, refresh, and then it'll actually give me my node commands. Oh, I said I want to go get the config file or the kubectl. Yes, I will also share that in the YouTube description. So yeah, so this is what is being run on those. Oops, sorry, you can't see that. Excuse me for still learning how to live stream. So these are the actual commands that are being run to add nodes into that server. Look at this, Nate. So yeah, this is why it failed. This 1803 is why it failed, because it's bad mismatched version. So with that, I will close out today. So just after this, as soon as we're off of here, I'm going to go upload I'm going to go, do any edits I need to do this and send things out to YouTube. So if you'd like to get this later on YouTube, go out to YouTube, search for the RanchCast, tell YouTube that you really did mean it as one word, and it'll pop up here. So you go to RanchCast. So please subscribe so I can actually say, hey, go to youtube.com/t/the RanchCast, because until I have 100 subscribers, I can't ask YouTube for that. If you need to reach me directly, I'm always available on Slack. I'm also available on Twitter. My name is Jason Van Brackel. I'm the Director of Community at Rancher Labs. Thank you for your time today, and I'll see you again soon. Bye now.